All right, everyone. Hello. I think we should start. It's a quarter after 1 in my watch. It's actually 16 minutes after 1. I thank you very much for coming to this seminar. I want to begin with a land acknowledgement. I want to acknowledge that the University of Regina is situated on treaty land that are the traditional homelands of the Nihiwa, the Anasenepek, the Dakota, the Lakota, and the Métis Nation. Our time on this land is temporary, and it is our responsibility and our duty to take care of the land and to protect the land. We hope that these lands will continue to be the home of many diverse people, and they will continue to protect and care for the land. Thank you. So today's presentation is titled Planning for a Net Zero Energy Future. And we're really pleased to have Doug Opseth and Carrie Gelowitz from SaskPower giving this presentation. This presentation is intended really to whet your appetites on these very important topics, because we will be following up with a symposium on the 26th, which will have a series of presentations from different speakers, and then we'll try to have a get-together, a beer and pizza for some informal discussion and that sort of a thing. So as I say, we're very pleased to have both Doug and Corey here. Doug is the Director of Generation Asset Management and Planning. He leads a team with the challenging task of ensuring the growing demand for power in Saskatchewan can be met. I'm really not going to do too much of an introduction. I'm really asking our speakers to introduce themselves. And Corey is a project manager for grid modernization, which is, again, extremely important. He plays an integral role in developing SaskPower's long-term grid modernization strategy and roadmap. So with that, I will hand it over to Doug and Corey. I do want to say that we're trying anyways to record this presentation, and we'll present it on the U of R Engineering website in the fullness of time.
Thank you. Well, thanks for having us out here today. I think, as mentioned, there's a bigger presentation next week. I won't be here next week, so I'll prevent the supply planning piece of it today. And we're a relatively small group, so feel free, as I'm going through this, ask any questions you have. I was on the road all last week, so I haven't gone through this. It's a new presentation we're using, so I'd love to hear your thoughts on it. But I'll view this more as a conversation back and forth on some of these energy challenges. As mentioned, I'm the Director of Generation Asset Management Planning at SaskPower, so I look after our capital spending on generation, but most of my time is spent thinking about the energy future, where we're going to get our power from the future, where it's going to come from, how do we get to net zero. Increasingly, some of the work involves nuclear power, looking at nuclear power and carbon capture and storage on natural gas and things like that. So this presentation will kind of touch on a whole bunch of different things. I'll go through it probably fairly quickly in the interest of time, but happy to stop at any point if you have any questions. We'll cover the current state, some of the supply planning stuff. We've been out talking to the public a lot recently. I think it's new for SaskPower to come out and really engage with the public on our future plans. I know Brett's been involved in lots of those discussions, but we've been having more of these discussions that will give some of the initial input that we've received back and what we've heard today and kind of what's going to happen going forward. So, can you do that, Doug?
No, I can. Oh, there we go.
So one of the things at SaskPower, we're committed to getting to net zero greenhouse gas emissions. It's been, one of our long-term goals. It's right now we're talking and committed to being there by net zero 2050, but still maintaining, safe, reliable, and cost-effective power for our customers. And so we're trying to balance all those things as we're going into the future. Next slide. One of the challenges facing SaskPower as we're looking to get net zero is we're still primarily a fossil fuel utility. Most of our energy, 20 years ago, we've been around for close to 100 years now. So it used to be all coal. So all this would have been coal-fired generation. Slowly we're retiring our conventional coal generation, and we'll have all that retired by 2029. Increasingly, our baseload supply is now being made up by natural gas. So we're still about 64% fossil fuel generation in our system. You know, we got more wind and solar coming on our system, and I'll talk a little bit about that and some of the challenges of wind and solar in our system. We do have some of our hydro assets and things like that. We sit at about 5,400 megawatts on our system right now, and we anticipate that growing significantly as we move out to 2050. You know, we're starting to look at scenarios that has our load doubling as we go to 2050 as more people electrify and things like that. So we're starting to think about, you know, how do we go from here to there over the next, you know, 25, 26 years. You know, next time. So one of the challenges being a fossil fuel utility is how do we get to net zero? And so this line kind of represents our plan and our thinking of what it was kind of before the clean electricity regulations. You know, we were planning to be net zero by 2050. This kind of squiggly line represents what our CO2 emissions are. The orange lines represents where they were in the past. And if you're wondering, that big dip right there that's COVID. That's when COVID came and people went home and energy consumption dropped. And when energy consumption dropped, our emissions went down. And then they came back up. And now we're on a gradual trend to get to net zero by 2050. You know, we made a lot of commitments, and one of the commitments was to be at least 50% below our 2005 levels by 2030, which we're well on our way to doing. And the challenge for us now is with the clean electricity regulations. And we have new up there, but they've been in draft form for a little while. We got a bit more details on what they look like earlier this year. We're preparing our thoughts on the clean electricity regulations to submit that. About 2 weeks, I think it is. I think early November they have to be back in. And the challenge for us is how do we go from here to try and advance it to get closer to 2035? And the reality is for us is that we can't. And we can talk more about the whys and stuff like that, but we can't get to net zero by 2035, as outlined in the clean electricity regulations. I think the province of Saskatchewan has been clear on that. I think other jurisdictions have talked about that. The reality is it's just the logistical challenge of trying to do that in 12 years. There's a supply chain issue of just getting all the equipment we need by that time. And the reality is, I'll get into a little bit, is some of the technologies we need to get there, we can't even build to get things like nuclear power and carbon capture and natural gas and some of those things. So getting there is not possible. So the work we're doing now is, you know, we're planning to this. Now the question is, can we get there sooner than 2050? Yeah, next slide. So as I said, so, you know, what's driving some of the factors influencing our business? Certainly our customer expectations are changing. You know, our customers are wanting different things, and that's a lot of what Corey's group is doing, and what he'll talk about it is they're looking for different things from us. You know, it used to be a one-way transaction. You know, we would generate the power and we'd sell it to our customers, and that's kind of how it went. Now our customers are wanting to put solar panels on the roofs. They want EV charging in their garage. They want more insight into what we're doing. So they want different things from us. And so we need to evolve for that. You know, we're starting to see the impact of climate change. You know, we are seeing the impact of climate change with hotter, drier summers. We're seeing just the impact of forest fires and things like that. So a lot of impacts on our business, which are causing us to change. Certainly emission regulations, like the clean electricity regulation being the most obvious one, but carbon tax and things like that are driving us to change. You know, we got industrial decarbonization. So we got a lot of our big industrial customers are looking to decarbonize their grid as well. And some of them have more emission or net zero targets even more aggressive than ours. Like some of the big potash companies, certainly any business that works internationally has a head office somewhere else. Quite often they have governance targets for emission reduction. They might be selling products where their customers are asking for the carbon footprint to be lower. And so when you're a high carbon emitting jurisdiction like us, that has an impact on our business. So they're asking us to get our emissions down and to help them get our emissions down. But and the flip side is they also want their power to stay the same price. So it's a challenge we're kind of wrestling with. You know, we see this creation of a low carbon society. We see electrification, which is a big thing. You know, we're starting to see that. You know, it's electric vehicles. It's, you know, as the rest of the economy starts to decarbonize, the way they'll do it is by, in some cases, it'll be by electrifying. As we clean up our grid, they will start to electrify. And so we're on the cusp of seeing that big electrification come. So when you're planning the grid and the system, it's a challenge because we know it's coming. We just don't know how quick it's coming. And the challenge we have right now is like when we only have, and we'll talk about the supply options a little bit, but we have lots of non-emitting or we have lots of emitting baseload options like natural gas. If you see your load jump now, and you have to build for that. Likely you're going to have to build natural gas. You know, if we had lots of supply options, we build non-emitting stuff, but there's a challenge of trying to time and understand that electrification. And then we see energy democracy and decentralization. So again, the need, customers looking for choice, looking to have the ability to be self-sufficient, to generate, have batteries, EV charging and things like that. And a lot of what we have to do is like, you know, I spend my time thinking about the generation side, which is old and needs to be replaced, but our transmission distribution system's in the same boat. And so we can't, all our customers want this stuff, but it's going to take a lot of money and it's going to take some time for us to get to the point where we can have our grid set up so our customers can do that stuff. I think, Brett, do you have a question? Look, I got a question. Okay, next question. Yeah, there you go. So our long-term supply plan. So we've had different versions of a long-term supply plan in the past. You know, we do different types of plans. We do our yearly supply plan, which is really tactical. And it's like, here's what we're doing over the next 10 years. Here's what we're building over the next 5, 6, 7 years. It's what we're building, where we're building it. And then as it goes a little farther out of the 10 years, but right now we actually go to 2035. It's, if we know we're building something, we may not know exactly where it's going yet. But what we're doing now is developing a long-term supply plan, which really is designed to not tell you exactly what your next step is, but to point you in a certain direction. And you know, when we're trying to explain this to people, and I'll use an analogy, and you can tell me if the analogy works or not. It's the way I look at it, it's kind of like you're planning a vacation. You know, I know where I am today. I'm here in Regina, and next spring I want to go to Disneyland with my family, my sister's family, my parents, a whole bunch of people. And there's different ways you can get there. You can fly, you can take a train, I can drive my car. And each way has its pros and cons. And before I make the decision on how we're going to go, I'm going to talk to the various family members and we'll decide what's important. Some people like me might say, well, I want the fastest, cheapest way to get there. My kids might want to stop and visit relatives. So you kind of get that input before you decide on the path. And the long-term supply plan is kind of the same thing. It's, we know where we are today. You know, we're a fossil fuel utility that needs to provide safe, reliable, and cost-effective power. And we know where we want to be in 2050. We want to be still providing safe, reliable, cost-effective power, but we also want to be net zero, and we also want to have likely serving a larger load. And so when I start to think of how do I get from here to there, there's different ways you can go. We can have a pathways, and that's some of the work we're doing now. And as we're analyzing this, there's pathways that have more nuclear power or nuclear power. There's pathways that don't have nuclear power and rely on wind and solar and other things. And there's pathways that have natural gas going right to 2050. And there's kind of an infinite number of pathways. And we're kind of working on 3 or 4 of them for the public to kind of look at that. And then to get people's input. They all start at the same point and maybe end in the same point. Some cost more, some cost less. Some have pros and cons. And it's really about deciding which pathway we're going to go down. And that's kind of what we're out engaging with the public on right now to get their feedback on some of that stuff. So what makes a plan effective for our supply plan? Certainly it's staying on top of assumptions. You know, they change all the time. We're constantly relooking. You know, it's about different technologies we're looking at, you know, redoing those assumptions, you know, things that maybe didn't make sense 10 years ago. We relook at them again now in light of, you know, needing to get our emissions down quicker and things like that. So we constantly are relooking at those things, costs and things like that. You know, we always update our load forecast. So it's making sure our load forecast, it's a huge input to our business, is understanding that. And it's becoming more complex. It used to be our load used to go up a couple of % every year if we were lucky. It was nice and steady. And it was going up largely residential, some business coming in, so nice and flat. The challenge we're in right now is it can go up or it can go down. Some of our customers are looking to self-generate, which might drive our load down, but we're also on the cusp of big electrification. So it's really important that we understand our load forecast so that we can effectively plan our system. You know, industrial standards, criteria. So we just need to have an industry standard way of planning, which I think we do. And so we constantly are meeting with other utilities, you know, different utilities. We're all going through the same sorts of challenges. So it's important for us to work with our utilities, certainly meeting with our customers, certainly our large industrial customers. You know, we need to understand they're the biggest consumers of power in Saskatchewan. So we need to understand their plans. And then we also need to understand and work with the public to understand what's important. You know, I'll say, again, at 20, 30, 40 years ago, we didn't really engage with the public. We would kind of make a decision what we're doing, what we're building, where we're putting it, and we'd come and tell the public, and we build our transmission line where we need to go. And increasingly the public knows they have a voice in what we're doing, and they're prepared to exercise their voice a little bit. And so it's important for us to get out and hear from the public. And it's not as easy to do things anymore. When we used to be able to go do what we wanted to do, I'll say life was a bit simpler. But it's challenging now because, you know, no one wants a transmission line generally near their property. No one wants stuff getting built near them. They have different things they want. So we need to make sure we're taking the input from the public and really, you know, understanding it and using it and showing them how we're incorporating that in our decisions. We need to set targets, check signposts. So we talk about signposts. That's really about, you know, we need to know when things are coming up that will cause us to change course. It's like, do we understand enough about electrification so that we'll see those kind of inflection points where we know we're on the cusp of big electrification or not? Do we understand technologies and things like that? So we need to look at that. And increasingly, we need to really plan around flexibility. We need lots of flexibility in our plans because the world is changing significantly more quickly than we had in the past. So this is our future supply engagement plan. So it's being largely driven by Laura Ludwig, who's sitting in the back there. So wave your hand, Laura. If you have any questions on the engagement stuff, Laura can answer them. So Laura's working closely with some folks in my shop and on developing this and rolling this up to the public. You know, we're on stage 2 right now of a 5-stage process, and it's really about understanding people's priorities. You know, we're just on the cusp of moving into the providing future supply scenarios for the public. I think that's starting next week, I think, somewhere around there. So we're moving into that phase next week. And all this will come with a draft long-term plan, which will incorporate, you know, our work, the public's work into this. And we're targeting that for early next year. And then we will finalize our plan next summer. And then, you know, this will be part of an ongoing process we have at SaskPower going forward. So we've been out in stage 1 and 2, and I think we've had tremendous interest for the public. I know I've been on some of these events, you know, I think we've had 15,000 surveys. So I won't get all the numbers here, but we've had lots of interest from the public. And I think it speaks to the interest the public has in the power sector. I know we did an online phone talk about nuclear power last week, and I think we had 7,000 people dial in for that online. So there's a big interest in the public in hearing about these things and providing their input. And so we've been out collecting all this input to this point, and I'll share a little bit of what we've heard up to now. Yeah, next slide. So, you know, what we've heard, and these are the kind of the customer key needs of what they want to, I guess, understand and know about. And one is understanding the cost of supply. You know, what do things cost going forward? They want confidence that all viable options are being considered. You know, I was on, I think it was CBC last week talking at lunch, and there's a lot of questions. Are you looking at this? Are you looking at that? So the public wants to know that we're turning over every rock and really considering all the options in a real way. They want trust and transparency. So they want to understand how we're making our decisions and what the inputs are. They just don't want to take our word for it, that this is the right path. So they want to understand some of that. They want us to understand future impacts of our decisions, and they want us to make, you know, equitable and fair decisions. You know, there's an urgency and timing for the transition. You know, how quickly can we make our energy transition? And not surprisingly, there's differing views on things. And I think talking to Laura today, I think the two most polarizing things that we're seeing are people's views on nuclear power and people's views on renewables. Are the two most polarizing or diverging views we see from the public. You know, next slide. You know, so what we've heard is a focus on efficiency first. What we mean by efficiency is it's energy conservation. You know, make sure we're being prudent in how we utilize our energy. You know? And so they want us to focus on efficiency first. There's an interest in creating economic opportunities here in Saskatchewan. So that gets to a discussion when you're talking about, do we import energy or not, or do we build things here in Saskatchewan? You know, so it kind of gets to that. You know, we need to leverage our strengths. You know, we need to support participation and decentralization, so give opportunities to our customers to do things. We need to be an innovative leader and a facilitator, and we need to strengthen our power distribution, so enabling all the things our customers want to do in the future. Next. So not surprisingly, it breaks down into four big key areas where the public are mostly interested. So it's the financial piece. You know, I said before, like if it was free, our customers would love us to get to net zero, but there's a cost to that. So people want to understand the cost. And different customers view cost differently. Some of our customers, it's about, can they afford to turn on their lights? You know, we've got, you know, as costs go up across the board, energy affordability becomes an issue. And then for our big industrial customers is about cost competitiveness. You know, how do we ensure that if their business is a heavy relier on power, how do we ensure that the power doesn't drive them to a point where they're not competitive with their neighbors? Particularly, we're sitting right next door to Manitoba, which has lots of legacy hydro assets. So they're concerned about cost for sure. You know, stability, you know, reliability is important to all of our customers, residential and certainly to our industrial customers. And then I think environment, you know, the emissions, you know, getting our emissions down, you know, what are we doing with waste? You know, as we're thinking about things like nuclear power, what are you going to do with nuclear waste? What are you going to do with, you know, wind turbines and solar panels when you decommission? I know there was a lot of discussion in the province recently about, you know, there's abandoned well sites, like oil well sites, but also people are getting concerned about abandoned solar farms and wind facilities. What happens when a wind developer, their contract ends? How do we ensure that they're actually decommissioning the site? So a lot of questions about stuff like that. You know, land use is a big thing. You know, different options, and I got a slide coming up on it. You know, different options have different land uses. And I think if you follow what's going on in Alberta right now, they put a moratorium on wind and solar developments for a bunch of reasons. And one was the concern over using agricultural land for things like solar and wind. So it's a concern for the public. And so one of the things we'll talk about. You know, some of the planning challenges we have. So, you know, we've got aging infrastructure at SaskPower. So, you know, we're close to 100-year-old utility. A lot of our generation assets, certainly our coal plants, are 50 years old. You know, and then the same goes for our transmission distribution system. We've got, you know, aging infrastructure throughout Saskatchewan, and the decisions we have to make are how do we replace that? How do you make decisions what you're going to replace and when you're going to replace it? Because we can't afford to replace all of it at this point. You know, more extreme weather. So that gets to, you know, we're seeing extremely high temperatures and forest fires. I don't know if people remember a couple of years ago, we had that frost issue on our lines, which took out most of the power in the province. So we're seeing more extreme weather events, which we have to plan for, and we have to harden our system around. You know, load growth uncertainty I spoke about. You know, renewables not always being there when needed. And I think there's a slide coming up next to talk a little bit about that. And then we're seeing increasing pressure on power rates. So all of this stuff is going to take money. And the decision that we have to make is that how do we ensure that we can now and in the future continue to provide cost-effective power for our customers in a way that they can afford? And how do you balance the need to bring our emissions down with the need to keep our rates affordable? What does that look like? Things like that. Is there another little piece to that one? Right here. Oh, go back to the next one. Push it again, see if another thing. Oh, there we go. So this shows two things. When I spoke a little bit earlier about, you know, renewables aren't always there when you need them. This shows, I think this was an average load day over an average of 5 days or something like that for a typical winter day. And not surprisingly, you see like people are getting up in the morning, their power's going on, they're cooking breakfast, and it kind of plateaus out. But then we see our peak at night when everybody's coming home and turning on their furnaces and their lights. And if it's really cold, they're plugging in their cars. And so we see that spike at the end of the day. And this kind of represents what we would expect to see from solar on a winter day. We see it comes up in the middle of the day, and then it peters out before we get to our peak. So the challenge we have with renewables here in Saskatchewan, at least from what we've seen so far, is that we can't rely on wind and solar to serve our two peak periods of the year. And the two challenging periods we have are first in summer, when it's really, really hot outside. And if you think about super hot days in the summer, and we saw, I mean, this summer and last summer we went to bed, 2 summers ago, we had, must have been 2 weeks or 3 weeks of 30-some plus days. Now, what you find is when we get to that extremely high temperature, we see our load spike. So we see, you know, after a couple of days of hot heat, everybody's turning their air conditionings on and they're leaving them on 24/7 quite often. And if you open your window to try and get a breeze in, what you'll find is there's no wind blowing because there is no breeze. And yeah, we'll have solar there to help serve those peaks, but that solar will disappear as the sun starts to come down. The second period where we have our peak load is the winter. And so this represents by a winter day. And that's typically when we hit the most energy consumption at any point is going to be in the winter months, where we'll see it's after dark and the temperature is cold. We'll see everybody coming home. They'll be plugging in their cars, turning on their lights, turning on their stoves. We'll see the energy go up. We definitely won't have solar because it'll be hitting, around 5, 6, 7 o'clock at night. So solar won't be there. And if it's really, really cold, if you think of a really cold day in Saskatchewan, you go outside, quite often there's no wind. And so when we get to that minus 30 some period, we won't have wind, and we won't have solar. So that's the challenge with wind and solar. We love wind and solar are a huge part of our plan to get to net zero. But the challenge is they aren't always there to serve our peak load. And that's why we need things like base load energy supply. That's right now that comes from coal and natural gas. And in the future, it's going to come from natural gas. Increasingly in the future, you'll see batteries play a bigger role in this. The reality is for us, batteries right now can help maybe shave off some of these little peaks right here, but you don't have, at least the technology and the cost isn't there yet for us to have batteries to supply us for days or weeks on end when we get to so many periods. So that technology will certainly improve over time, but until it does, we require baseload energy supply. And, as we're moving to be net zero, increasingly we need to find ways to move away from coal and natural gas and move towards things that are non-emitting, things like carbon capture and gas, things like and potentially nuclear power. Next slide. Cost is a big thing. So this is the levelized cost for our different supply options. Levelized cost, for those familiar with it, is an imperfect way, but it helps to compare supply options as we go forward. Just for comparator, it doesn't include our transmission distribution costs, but includes all the other kind of life cycle costs for those things. The cheapest form of energy we got in our system right now is wind and solar. The challenge for them is they're not always there when we need them, so we need something to back them up. And right now it's primarily natural gas. If it wasn't for the emissions from natural gas, if there's no carbon tax and clean electricity regulations, and we didn't care about emissions, we just keep building natural gas. It's a great form of power. It's flexible. It's great for backing up renewables. But increasingly, as we need to bring emissions down, we need to make a transition away from that. And so as you start to see, as you come down the scale here from those ones, imports, biomass, geothermal, natural gas, then we get into the things that are less emitting. These things like natural gas with CCS, nuclear power, coal with CCS and hydro that are kind of in the same price range. Typically, they kind of overlap. And those are the things we're looking at post 2030. And then I guess any of those things, biomass, geothermal, that have a big range on them, it's just there's so much uncertainty around what those things cost in terms of that. So you can go to the next slide. Happy to come back to this one if those people have questions about it. I talked about transmission distribution and the costs on that side of things. We spent about $8 billion developing our transmission distribution system over the last 90 years, and we expect over the coming years to have to spend that much more. And that's not just, that's kind of to replace what's aging and what's old and needs to get replaced. This doesn't account necessarily for all the infrastructure that's required to facilitate, where we're going in the future. We've been having lots of discussion about how do we build out our transmission in the system to take advantage of more wind and solar. Certainly all of our wind right now is down in the, I guess we'll say, traditional generation, we're planning gas and things like that. We typically locate right next to where we need the power. Saves you having to move the energy big distances. But the challenge with wind and solar is a lot of our really good wind and solar is in the Southwest. And so we need to find a way to take thousands of megawatts of wind and solar from the Southwest and move it up closer to Regina and Saskatoon. And that's billions of dollars of infrastructure likely to facilitate that. So it has a big cost. Roughly every billion accounts for a 2% rate increase, which coupled with other rate increases starts to add up. Plus another 1% to cover, maintenance and land payments and things like that. So there's a big, when I talk about the cost, cost is a big driver for us. It's a concern to our customers, and one of the things we're trying to manage around. Yep.
Is that $8 billion in current dollars, or is that just the number we hear added out?
I'm guessing that's in current dollars, backdated to now, estimate what it would cost if you just did an overnight kind of blanket replacement of all that. I'm guessing that's the number.
I think so.
Yeah. So it's basically get rid of it, replace it tomorrow is $8 billion. So yeah, that's what I'm guessing anyway. Next slide. the cost to reach net zero, there's different ways of getting there and a lot of uncertainty, but we're estimating about $40 billion to get us to net zero by 2050. So it's a big number out there. And so when we're talking to the federal government, it's one of the things we're talking about is the desire to get to net zero. It's our view, and I think the province's view, that some of that should come back from the federal government to help that energy transition, because it's a big cost. $1 billion, it is obvious, but $1 billion from the feds avoids $1 billion worth of borrowing. Every billion that we borrow costs about 60 million in interest payments over a year. And every billion of funding reduces the impact to our ratepayers by 2%. So certainly we're looking to find some federal government support to help offset some of the energy transition costs. Yeah.
I want to ask you said the incremental cost at 10 billion, incremental to what? And where's that in relation to 40 billion?
Incremental, I think it's incremental to what it would cost anyway, I think. Is that what we're? Yeah.
Okay, so the 40 billion would be like total costs. Without that, it'd be 30 billion.
Yeah.
With it, it'd be 40 billion.
I think something like that. I'll double check. I'll get you that exact figure. Okay. It was in the notes, and as I said, I was on the road last week, so I didn't have time to dig into every detail as much as I can. So, but I'll get you the exact.
I can ask after too.
Yeah, it's a big. I think it's a big number. I say just building for a doubling of load is a big number, and then you tack on billions on top of that to get to net zero. You go to the next slide. So what do we have available before and after? So as we're planning out our system, we're always looking at a big chart of saying, well, what do we need to build and when do we need to build it? And I spoke about the challenges of getting to net zero by 2035, and this will kind of highlight it. Though if we have load going up today and we need to build something, it comes from before 2030. It's coming from one of these things. If we're going to build lots of wind and solar, but as I said, that's intermittent, so we need baseload energy. So if we need baseload energy right now, where it's going to come from between now and 2030, if we build something, is going to come from natural gas. So we have plans to build another large combined cycle gas plant up near, it's called Aspen right now. It's up near Jansen, kind of southeast, I guess, of Saskatchewan. So it'll be a large gas plant because we're retiring coal and we need a plant of that size to go in. We have things like imports, wind and solar. As I said, will play a big role. And then we've got some other smaller forms of generation, biomass, flare gas, distributed energy resources, demand side management. They're all important pieces, but they're relatively small in terms of helping meet our energy supply. Certainly battery energy storage is something that you're going to see us building a lot more of. But again, it doesn't really replace baseload generation. Typically we're looking at battery energy storage to help manage our intermittent generation in our system. Quite often it helps manage transmission issues. We've got some big customers right now that can turn on or off really quickly, which causes a lot of issues for our neighbors. And so batteries are great because they can be there to provide that energy really quickly so we can balance our system, or they can absorb energy and things like that. So they provide a lot of services, and you're going to see us building lots more batteries going forward. But as I said, as we start to move towards being net zero, we need to start developing new technologies. But some of these technologies aren't here yet. That's like Saskatchewan hydro. We're re-looking at all the hydro sites we have in the province to see what hydro sites we could look at again. And there's a few sites we're contemplating re-looking at, but there's not anywhere near enough hydro in Saskatchewan to offset, replace all our coal and natural gas. And some of the hydro that you'd look at are in incredibly sensitive areas of the province that we probably, even if we were legally allowed to build there, or you could get through the environmental impact assessment process to get permission to build it, we probably wouldn't want to build them anyway. But there is some hydro we're looking at again. There's a lot of work on nuclear power right now. So a lot of our effort is to develop options around nuclear power. So it is an option to choose from. I think you're seeing a lot of interest around the world in nuclear power for the same reason we're looking at it. We don't have a lot of baseload, non-emitting energy supplies here, but nuclear power is one of them. It's available 24/7 and produces no greenhouse gas emissions. We're home to some great uranium here in Saskatchewan, so it's an option we're looking at. But we're still years away from making our decision. And even if everything goes great with nuclear power and we proceed in 2029, we decide we're going to build it. Our first facility comes online in 2034. And that'll be for 315 megawatts. And as you remember, if you remember back that pie chart, our current load is about 50, or we have about 5,400 megawatts of installed capacity right now. Our peak load is a little under 4,000 megawatts. So 300 megawatts is kind of a drop in the bucket. So we will need other things, but it's a step in the direction. If we decide to go down the path of nuclear power, which is one of those, potential pathways to get to net zero by 2050, you could see us building more nuclear power in the future. But this is the first project we're looking at. Natural gas with CCS, again, is one of the technologies we're looking at. We've got lots of experience operating the world's only large carbon capture and storage facility at BD3. And we've got that facility running really well right now. And now SaskPower as well, lots of jurisdictions are looking at the role carbon capture and storage could be. I'll say it's a transitionary step to allow you to continue to run natural gas, but allow you to bring your emissions down.
But it's slated to shut down 2029 as well?
BD3 can continue to operate beyond 2029.
Because it has a CCS?
Yes. Whether it can operate beyond 2035, that's a question of the electricity regulations. Yep.
Natural gas, would it be converted coal plants to natural gas at this, or would you be building new stations?
Well, one of the things we are looking at potentially converting some of our existing coal plants maybe to natural gas. But really it's looking at either retrofitting existing facilities. Like we've got two large combined cycle gas plants right now. One's in Swift Current at our Chinook power station. We've got another one that will go into operation early next year, just outside Moose Jaw at Great Plains. And we've got our Aspen plant planned for up near Jansen. So we're looking at the ability to retrofit some or all of those facilities, potentially with carbon capture and storage, but also then look at what would it take to build a brand new facility with carbon capture and storage as well. So a lot of that work is focused around those three areas. So, but a lot of jurisdictions, just like, there's an awful lot of, if you see a lot of interest in nuclear power and looking at nuclear power again as a not at any baseload supply. There's also a lot of interest in jurisdictions like Saskatchewan that don't have a lot of hydro potential to look at things like natural gas and CCS. And then hydrogen is one of those options that we're also looking at. But I'll say even the jurisdictions that have lots of hydro, they are starting to run out of the easy to build hydro facilities. And I think you're going to see a period in Canada where once we go to full electrification, if we see the load in Canada double, there likely isn't enough hydro potential there to serve all of that load necessarily. So you will see other jurisdictions starting to look for other suppliers. Maybe they go back to build new hydro again, but they will also probably look at some of these options as well. Certainly nuclear, I would expect. Next slide. One of the questions we get asked a lot is life cycle costs. So we always talk about emissions and things like that. So this is some work that we came out of the United Nations Economic Commission for Europe on the life cycle emissions for different technologies. So if you're going to ask me lots of detailed questions about this, I didn't pull this slide together, but I can certainly get the answers. But I think it's intuitively makes sense. I think you look at the things with the biggest emissions life cycle. This is right from digging the stuff out of the ground that goes into making it, the fuel and all that kind of stuff. Intuitively, you see, well, coal with CCS has a pretty big emissions footprint, right from getting the coal out of the ground, all the concrete that goes into construction, everything else. Natural gas with CCS a bit less. Well, that's coal without CCS, it's just unabated coal. So it's basically on our old coal plants, tons of emissions footprint, big life cycle costs. Natural gas with CCS, coal with CCS, and then they start to get smaller when you got natural gas with CCS going all the way down to nuclear power with the lowest life cycle costs. And I meant to bring this little fuel thing along with me, but it's, it makes sense. When you get down to nuclear power, it's just so energy dense, it takes a very small footprint that ends up with a small life cycle costs. So, but happy to provide more details on this or even the reference to this report. So, next one. The next big thing we get asked about, this is estimated land footprints. A lot of questions again about, how much land is this taking up? And we're starting to see, certainly you see it in Alberta, when they kind of put this moratorium on solar and wind, is concerns about agricultural land being taken up by wind and solar. And I think we got lots of land and solar, or lots of land in Saskatchewan we develop, but it is a concern for people. And we certainly see it when we're talking about different types of generation, because you look at the footprints that go into some of these. And again, it goes from less energy dense to more energy dense, where you need, if you're a less energy dense thing like wind or solar, you need a big area to collect what you need. to generate your power. So you're looking at a 200 megawatt wind facility taking up 30 to 40,000 acres. So it's a big footprint. Oh, yeah.
This doesn't seem to cite that land can be used simultaneously for other uses, unlike with hydro, for example.
Yeah, it's again, this is just kind of representative of kind of the footprint required, but you're right. With wind and solar, certainly, I guess I'll say with wind facilities, you see cattle grazing around them, you can farm around them, but it does take up a big land area. Solar, on the other hand, it takes up, and it's pretty much, there's not much you can do with that land, and it takes up a big footprint. We're out siting some solar facilities now, and it takes up a substantial amount of space that isn't really used for something else. So you really want to, when you're in a place like Saskatchewan, Alberta, lots of farmland, you certainly want to be careful when you're siting these things to avoid taking up good farmland for this. So you really want to find marginal land and stuff like that. But sometimes you're not able to do that. You end up
marginal land like giant roofs.
That's certainly one option. Certainly we get a lot of questions about roof mounted solar and stuff like that. I'm happy to have a chat about that as part of this, but certainly that's one option to serve some of that. But when you're looking at a cost basis, like the cheapest way of getting solar is a big solar farm, but it does take up a lot of land. And then you go all the way down to things like nuclear power, which take up, because they're so energy dense, they take up very small footprint for what it takes to generate them. And then we got biomass and natural gas, again, take up relatively small footprints for their size. Yeah, next slide. End of life, another question we get asked a lot is, what are you going to do with these facilities when they're done? Again, it gets kind of into the life cycle cost of things. We've had a lot of concern raised by RMs and things like that about what are you going to do with wind farms when you're done with the contracts? How do we end up in a situation where we don't have developers just walking away from these facilities and leaving foundations and things up? So certainly we have something. No, it doesn't. Certainly something we have to consider. Like we factor that into our contracts and stuff, but certainly something people are thinking about. When you got solar panels too, I don't know if you can recycle solar panels in Canada yet. I know up until recently you couldn't. I know Europe was requiring it, but a lot of solar panels we see right now are ending up in the landfill. I think at some point there's even people recycling them. Certainly for wind turbines, there's a lot of steel and things like that, so recycling going into it. But certainly the end of life is something we have to consider for all of our assets. And certainly as we're getting near the end of life for a lot of coal assets, we're certainly thinking about how do we decommission those in an effective way and plan for that. Yeah, next slide. I'll go through this quickly. Nuclear power, I think I'm eating Corey's time here, but nuclear power, something we think about. When people think about nuclear power, the question we get quite often is, what are you going to do with the waste? And certainly the pro of nuclear power is because it's so energy dense, it produces very little waste. If you're given the opportunity, if you go out to the OPG website or you go out to Darlington Nuclear Facility and you walk around this facility, there's very little waste that has to be stored. But the waste you do, certainly the high level radioactive waste, which is a very small volume, it has to be safely stored. And right now it's stored on site. The long-term plan is to send it to a long-term deep underground repository where you'd store it. But right now you do have to manage it effectively on site. And that goes right from the low level waste all the way up to the high level waste that people think about, the spent fuel rods and things like that have to get stored on site. But when you walk around the facility and you see if you walk around a coal facility and you see the ash lagoons and things like that and the waste that is on site, and you walk around a nuclear facility and you see how very little amount of waste has to be stored, it's quite significant how small amount of waste it is. Yep.
I have a question about the Darlington site.
Sure.
So SaskPower in conjunction with OPG and just power on it.
Yep.
Do either of those three have kind of the numbers on perhaps a future presence and value of the stream benefits that because I'm looking at the feasibility of this SMR right now, and I'm kind of buying.
So you look at the economic benefits of doing SMRs?
Yes.
So there was a conference board report, which we could certainly get a copy of.
Yeah, that would be awesome.
Which spoke to that. I think there's an updated conference board report coming out in the near term, which will speak more specifically about OPG and Darlington, the economic benefits around that. But certainly there's one report right now that was released, and we'll get you a copy. We can get a reference to it that talks about some of that. Yep. So certainly waste is a thing you got to manage on. You go next slide. And the next slide is similar. What happens to the waste? I won't get into details on it, but you basically take the spent fuel out, it goes into cooling ponds, then it goes into where they store it on site, and then eventually it goes into long-term repository. And this is what I was going to bring, a little tiny demonstration of fuel cell, what it is, but it's very tight, it's the size of your thumb. and it's equivalent to, a ton of coal and things like that. So it's just very energy dense, things like that. But something you got to manage. The next slide. So I'll go quickly and then I'll turn over to Corey. Happy to stay longer to ask any questions after this. So, what do we see in the future? This kind of a transition to Corey stuff. I said earlier, our customers are expecting different things. We envision our customers in the future to be driving electric vehicles, and they'll have, heat pumps. They'll have solar panels on the roofs. They'll have batteries in the garages, and they'll be sending energy back to us, which will go to their neighbors. And they'll be buying some from us occasionally, and we'll see things. So we're definitely seeing our customers changing, and a lot of that, to facilitate a lot of this, is the work that Corey and his team are doing. So we'll turn it over to Corey.
Awesome.
Thanks, Doug.
Oh, sure. Yeah, go ahead.
I was noticing that you didn't talk very much about geothermal, and even on that graph where you had the pricing, it was quite a huge range. And I guess I wanted to understand why you haven't talked very much about geothermal, and whether you felt that it could be a good source for the base load.
Yeah, I think there's a potential there. So there's a company looking at geothermal right now. When a lot of people think of geothermal, they think of places like Iceland, where you got like volcanoes and you got like boiling water and steam coming out of the ground. The reality is we don't have that here. But if you go 3 kilometers underground, we got this big ocean of fairly hot water, 120-degree water. So it's hot water. The challenge is going to be how do you go down 3 kilometers, take out a very brackish solution, bring it to the surface, extract the heat, put it back under the ground, and do that in an economic way. And the demonstration project that's proposed right now is going to try and do that. And certainly when we see that proceed, and certainly hopefully it works, if it can work, then you could see that replicated, because there's under the southeast part of Saskatchewan, there's a whole bunch of this deep water. Right. So if they can do it, then you could see it replicated. I don't anticipate that replacing all of our coal and natural gas anytime soon, but certainly a technology we're looking at. But right now I view it more as a kind of a small project with maybe some potential.
Yep. But there's a fairly large expense to get access to it.
Well, you're drilling, until we drilled our Store well, which went down 3 kilometers, that was the deepest well. This is equivalently deep. And the challenge you've got is when you're extracting that water there, to get it up and extract the heat in an economic way. It's very brackish water too, so it has a tendency to precipitate out, to cause issues with equipment. But we're certainly hopeful that that project goes and that they can demonstrate that the technology works. And if it works, then you could see that project replicated.
Thank you.
Right.
Just a quick question on the supply side of things. I mean, I've been thinking a lot about the clean electricity regulation.
Yep.
And my understanding is the federal government modeling has shown they think it's possible to meet the regulation. And I think that's different than saying it's possible by 2035, because some of the plants you're building now can still operate past 2035. Moose Jaw can go till 2044 as a conventional gas plant. Other plants can run at 5% capacity annually. So what is the difference between sort of what you're modeling and what the federal government's modeling that makes you have this difference of opinion, where they're saying that you could meet the regulation and you're saying you can't meet the regulation?
Well,
and a follow-up would be, what would have to change for you to feel you could meet the regulation?
So a couple parts of that. So what's different between their model and ours? I wish I could tell you, but we can't see into their models. So they have these models they run, and they come and say, well, the solution for Saskatchewan is we just move energy between Manitoba and BC and stuff like that. And if you just build wind and solar and stuff like that, you can solve your problem. We say, well, when we model our system, that's not the case. And when we ask to see their models, they won't show us their models. They'll tell us kind of what the outputs are, but they won't let us see what's inside the models right now. So we're hopeful that they will share more of that, because it's in our interest and their interest to get everything aligned. So we're looking at the same things. And right now, when we look at the future, we see it very differently. So that's a challenge. When you talk about the clean electricity regulations, why we can't get there, one is it's not enough time for us to get there in 12 years. The reality is, like, we're building our Aspen gas plant, which is something we know how to build. It's completely modular. It takes 7 years from the day you want to go to the day you have it in service. And we only have 12 years right now to replace a lot of our fossil fuel generation. Yeah, we can run some of it at low percentages under the clean electricity regulation, but we're not sure if that provides enough certainty for backing things up on our system. There's a massive cost we talked about. So even if we had the time, and even the supply chain for that, I didn't really talk about supply chains, but one of the challenges we've got in terms of getting things done is every other jurisdiction is doing the same things we're doing right now. So the lead times for any equipment is getting longer. It's taking longer to build it. There's a big cost to do it. And some of those technology aren't there yet. So certainly, I think there's a step in the right direction with the clean electricity regulations and some of the things. But the ability for us to only run our gas beyond 2034, some of our gas plants at that 5% level, I think it's 450 hours a year, is likely not enough for us to be able to manage what's on our system.
Yeah, so the comment period is now, so there'll be some of the things you'd be asking.
We're providing a lot of comments back, so we're vetting this. This is the province is responding on behalf of all the utilities in Saskatchewan, so we provide our input to the province, and they will be compiling all of these responses back to the federal government.
Great. Will that be a public submission, or is that private, or how's that work?
Don't know.
Okay.
I know we'll make our submission. I'm guessing. I don't know whether that becomes a public document. Probably it doesn't become public. I don't know.
Yeah.
I'm guessing maybe it doesn't become public. No, I'm looking forward to reading it too. So I think whether it's public or not, we can certainly find out about that. I think ultimately this will get fed into the federal government. We're hoping there'll be some realization from the federal government. I think we're starting to see some of it now, the understanding, because it isn't just Saskatchewan. You know, sometimes there's so much politics in this that it's just like they're just button heads and they'll disagree on everything. But I think what you're hearing from Saskatchewan, Alberta, you're hearing it from Ontario. They're looking at building gas again. You're hearing it from the Maritimes. Jurisdictions just can't get there by 2035. That we've committed to get there by 2050. We're trying to see what we can do to maybe accelerate that a bit. But the reality is 2035 isn't a reasonable timeline to get there. And you know, it puts us in a bind because when you set rules saying you have to get somewhere that's impossible for you to get to, it's like, well, what do we do? But certainly, you know, we're doing what we can to inform the federal government on the challenges by providing our modeling information. We're providing our thoughts on how they need to change regulations. We're also looking at the federal government to say, like, regardless of when it is, 2035 or 2050, it's going to be massively expensive. So we need to find a way for money from the federal government to flow to help pay for the energy transition. And we saw some of that come for SMR funding. There was 74 million in funding for our SMR project recently, but that's a drop in the bucket when you're talking tens and tens of billions of dollars that's required.
Thanks.
I'll be sticking around after, so if you have questions, happy to answer. Oh,
yeah. How much solar power generating does SaskPower actually own versus just contract or buy?
I don't know if we own any. I think it's all contract. I think it's all IPP. You know, a bunch of years back, we made the decision to go down the path with IPPs, or IPPs are independent power producers to provide, you know, renewable generation in the province. I think all of our solar right now is through private companies, either like there's net metering customers.
I'm a net metering.
Oh, there you go. So it's net metering. Yeah.
I've always told people that I own more solar power generating technology than SaskPower, so I just wanted to check.
I think you're probably right. I don't think we own any. We might own some on top of the science center, which might not be working.
That's the only one that I know of that you own, yes.
But I don't even know if we own that. And also I don't know if it's actually working right now.
It's 20 years old.
Yeah, so I don't think we own any. I think we contract for all the wind and solar in the province right now. So.
Yeah, thanks.
Thanks, Doug. Well, thanks. As macro as Doug sees the world, I see it in a micro way. So Corey Gelowitz, I'm the portfolio manager for distribution transformation, which is a fancy way to say grid modernization. So this slide, you know, Doug and our supply planning people look at it from what's the impact on supply, right? We're at 300, 400 megawatt units. How do we do that? My team and I look at this at the other end of the equation. In your subdivision, we typically have one transformer serving 22 houses. When you add an EV and your neighbor adds an EV, essentially your house load is doubling, because your house, typically you pull about 4 or 5 kilowatts at peak. EVs charge at 7 to 20 kilowatts. So it could even be more than doubling. So we could start to see constraints on the distribution system all over the 550,000 customers, 200,000 transformers. So this to me is a massive micro issue that's all over our system, and we have to figure that out in about 180,000 ways. So Doug only has one supply plan to deal with. Yeah, you know, both are monster issues, but that's what we're dealing with. It's been a little bit hidden lately because people love to talk supply plan, and it is very, very important. But if we can get the energy to the substations, we've got to get it out to your house. So the lines, the transformers, the next line into your house, the meter, all that has to be sized to suit what. And that's the big challenge. Is it 7 kilowatts? And we have models that take us up to 65 kilowatts a house. So it's just a massive infrastructure problem. So that sets the stage. So I'll talk to you a little bit about, if I can, and I can't. I'm in a technology field as well. So any engineers in the room? It was working, Doug. Anyone have any tips for me?
Really?
It's just page down, arrow down. It's just locked up. So want to go for it? You seem.
I've done this before, so.
Any questions?
While we're fixing that, yeah. I'd think about this and ask if you'd like. What's your interest in self-generation, EVs, things you can do in the energy electricity world? Think about that. I'm open. That's kind of where I live. Is what does the individual people? What do you want to do, and what do you need to do? What do you want from us?
Well, I was gonna ask, just like, is there any more enticement to the net metering, sort of, to try to help the customer offset their own house for that EV and electrification of their house? Because the first net metering program was awesome, right? A lot of people loved it. Now it's like, oh, you only get 7 cents back. It's not as enticing, but if you want an EV, which a lot of people have, and some will only charge at 120, so it doesn't take as much of a peak on your load, but to offset their own house, which is on, like, now, like you said, it's on such a small level to actually help with the entire issue, but as the issue of the distribution to each house, that could help.
Yeah. Always a good question, and it is something we're spending a lot of time on. So the one challenge with the net metering program is that you'd like energy 24/7, 365, and your solar's there when the sun's up, right? And then you're going to have good irradiation days where you don't have much solar, snow days. So the solar's good when it's there, but then there's another time frame outside of when the sun's down that you're completely relying on us, right? So are you going to charge when your solar's there? Or are you going to charge when your solar's not there?
Some people are doing batteries for that.
There you go. Thank you.
Like in their house, like, yeah, I do know that is happening.
Yeah. And I owe Alana, she technology problems. I couldn't get the parking app to work, so I owe you. Thanks for the planned question. She paid for my parking, so thanks. Yeah, this is the big challenge, right? Is we're looking at this from the system side, and I'm a Saskatchewan boy, and we have to keep the system affordable and operating. How does this really work? Well, you know, when people add solar, it gives us energy during those hours of the day. So basically what we do is we pull back on our natural gas output till that solar's gone, and then we ramp it back up. So we don't get rid of iron in the ground. We just choke back the fuel we burn till the solar's gone and ramp it back up. And now we're serving you whatever you do in the evening, overnight, and in the morning, we're taken care of. Solar comes on during the day. If you don't have a battery, it just hits the grid, right? So net metering's got to contemplate all that. As more and more people add solar, the value of energy during the day inherently becomes less and less because we have more and more and more of it, right? So in an open market scenario, which we're not in, that's going to have to be we're starting to look down those roads. So we're trying to find a way to price net metering so that it still helps people, but it's not passing cost on to the other members of rate base.
Has there been discussion on time of day bill like that or no?
Yeah, you're feeding right into my part. This is fantastic. Absolutely. We need to have smart meters on everybody's house, and we need a billing system that can handle time use rates. Absolutely on our roadmap. We have a roadmap for grid modernization out the next 5-6 years that has about 71 elements. One of them is time use rates. Reliant on us having meters for everybody. Absolutely. And the thing about that we see is that if we had, 5 cent times a day, 15 cent times a day, and 50 cent times a day, people who can afford EVs and solar on the roof and probably I'll just pay the 50 cents in charge when I want it. So we're gonna have to find tactics so that we're not creating a peak that Doug has to build supply to hit that peak, and we have to build feeders and lines and transformers all over the system to reach a peak. If we can move that peak off here somehow, we only have to build infrastructure that big. Back to the energy efficiency thing. If we could get everyone to save 10%, that's 10% of 8,000 megawatts. That's how many $1 billion we don't have to spend and put into rate base. That's how many $1 billion of lines we don't have to oversize for that 1 hour a day everybody's peaking.
I could help you move that,
Yes,
that graph over, that peak over. So people with EVs, they can charge up on that cheap power there and then deliver it back at the demand, in the middle there. If they have a vehicle to grid where they're parking at work or at home.
You're hired. Absolutely. And that's our challenge is how do we build all the programs and get the tech in place so we can do that? Because right now we're absolutely blind to our system. We don't have smart devices out there to see what's the energy flows on our lines. I don't want to scare you guys, but we don't see the energy flow on our system. We see it at the substation maybe, but we don't know where it's going and what's happening hour by hour, minute by minute on the system. We don't see it. So that's like air traffic control running blind. The plane left. Let's see when it lands.
Where do you have to read the smart meters from? Do they read at the head office or do you need to be in an area?
Yeah, we've got a system all set up with towers out there reading. It comes back to our technology systems and into databases and back into all of our systems. Yeah. So we've got about 75,000, 80,000 smart meters out there. Most of our commercial industrial, only about 26,000 residential. We're getting back to mass deploying and it's going to take a few years to deploy 500,000 meters. So that's ongoing. We're also putting smart metering in our substations on all of our line devices so that we can see everything in real time. But until we can see everything in real time, we don't know what's happening moment by moment on every feeder. So when people add EVs, we don't know when we're going to overload a transformer. So we're kind of planning the system on all those hyper local spots, 200,000 of them, hoping we're right. So data is going to help us make better investment decisions.
Can you give incentives for smart EV charging then?
It's an option. We were looking at a lot of things. So I think what's going to happen, if I may, is there's another session coming next week. And this is the first time that I've been out talking at the distribution level. So we want to start looking at all those things. Yeah. What can we do? If we give incentives, where's that money coming from? Is someone else paying for it? So there's a little bit of a trade-off on affordability. Those people that can't buy EVs and solar, as we help people who have money to do it, hopefully we're not transferring the cost to them, right? So there's a lot of things to balance, but we're looking at all that. Yeah.
My only other comment is the company cap of like 500 kilowatts of solar per company without like switching to that. I think the IPP. So that's a deterrent for companies who have big buildings across the province, and you've limited us on how much solar we're actually allowed to have. So.
Yeah. And again, there's limitations on the system. You're right. And then there's kind of the business limitations. We're trying to figure out how to handle all this, right? Like if we let it free flow and just everyone can build what they want, we'll end up like California's been through this, other jurisdictions have been through it. You get the duck curve, right? You literally get times a day when the energy is overwhelming, this generation's overwhelming load, and you're giving energy away for free because you have no place to put it. So it's got to fit the big equation. That's what I was hoping to share is we have to take care of every hour of the day of every year. People with solar on roof want to lower their bill, but you're only giving me energy when the sun's up. So let's get into a deeper conversation. Let's come to my side of the table. I'll come to yours. We haven't been great at listening. How can we solve this problem without hurting the system and hurting low income people? And we got to figure that out.
Office company though, like that's pretty sustainable. Only needing load during the day, right?
If it matches, absolutely. Yeah. And those are things that we need to talk about is we may have programs for 8 to 5 Monday to Friday companies, right? But again, in winter, they could still be operating full on at 5 and their solar's gone. So batteries is a big one we need to start talking about at the residential small business level. Absolutely. That's what I'm pushing, but real time now, we're talking about those things. So I have another hour. Yeah. Whatever time you need. I mean, I'm happy to stay. How's my parking, Alana? I've got another hour. So these are just some stats that show you the magnitude of the distribution system, and I'll show you. Every blue line is a circuit. So that's the density of the distribution system in Saskatchewan. And we have 1 million people. We have 1.2 million poles. And this stuff's a lot of it was built in the 50s and 60s, and we have to replace 50-75% of it in the next 15 years.
So
how big do we build?
Yeah.
Sorry?
It's like the highways in Saskatchewan.
It's probably, yeah, if not more. I don't know. It'd be nice to see. That's a good stat. How many kilometers of road do we have in the province? The other interesting stat is we have we serve 3 people per kilometer line. The average utility in Canada serves 12. So we have 1/4 of the density to pay for it. So if we make a mistake and oversize all this infrastructure, we get to pay for it. So we want to have data to do the right thing. We want to incent the right generation where it's a value to the system. We don't want to incent generation where it's not. We've got to be very hyper local in our decision making. We need data to do that. So that's what we're doing. We're going to modernize the grid. We got to get smart tech out there. I've said that, smart devices on all of our equipment on our customer sites. And then that data is going to allow us to see what's going on, understand what's going on, then say, okay, that's what solar's doing here. That's what EVs are doing there. Let's invest money this way. Right now it's right, not a lot of bullseyes. So and then all of that leads to designing solutions to meet what customers want. But today there's a little bit of guesswork in that. So, you know, Alana and the fella in the back there, we need data to start making better decisions. We're not going to stop making programs for customers, but we're going to get better at it. So it's not causing collateral damage, right? This is our kind of 5-area plan: modernizing the grid, the boring stuff that I deal with every day. Then there's electrification, all that. When is that stuff going to happen? When are EVs going to go parabolic? When are electric furnaces going to show up? God forbid they do. They're 20 kilowatt loads. You're home again, you peak at 5. So if you have 2 Ford Lightnings and electric furnace, you could arguably peak at 65 kilowatts. Right now you're 5. So that's 10 times the infrastructure. So we hope that doesn't happen. We got to figure out ways to handle that. Distributed generation, we'll own some, customers own some. Can we use it to offset load at peak times? Can we export? We want you to export it. And what's the locational value and time value of that generation? So I hate to burst, but we have a 300 kilowatt solar unit on our Yorkton building. So sorry about that. I think we might have 300 kilowatts out there. So, but grid hardening, we have to figure out new ways to physically rebuild the grid. We can't just build it one for one. What we built in the past, upsize it. We have to get much more creative and find ways to build subdivisions differently. The rural areas, the north has its unique challenges. We've got to build infrastructure differently. It's going to be too expensive. We had a guy, quick anecdotal story, if I may, and in Saskatchewan, a guy won the lottery and he just pimped out his house, for lack of a better term. He had put in a 3-car garage with 3 EV chargers. He asked for, your house is 100 amp, maybe 200 amp service. He wants a 600 amp service. Okay, we have no reason not to do it. But because typically people only went from 100 amp to 200 amp, our customer policy is a little bit old, antiquated. We do it for free because 100 to 200 amp costs us nothing. So him going to 600 is free. We had to bore new cable under 6 lots, his neighbor's lots, come up, put in a whole new service. It was $54,000. So how many times can we do that as a solution? Can't. So we have to be working with our customers, because when customers do what they want for their interest, I'll have at it, that's fine, but we have to make sure we're passing the cost on to the right place, right? So those are the things we're dealing with on the business side.
Actually, the question that I had earlier was actually about this. So in terms of like the demand side management piece, it seems like it's such a crucial part of the conversation, but it's like kind of tacked on to the end of the conversation, right? But when we're talking about like supply, it's kind of based on this assumption, which is mostly true, that our needs are going to increase and increase and increase, but it doesn't always seem like we're balancing it with the conversation about like how much power use is maybe too much power use, and how can we really be shifting like overall, how we use the dollar on the day to day, and just like how does that fit within the hierarchy of sort of what you're looking at, because it seems like 50% harder.
I owe you bride money too. That we talk about that so much, that if the best money spent is lowering the amount of energy you're going to use, understanding your impact as a consumer, how we're using it, how can we help educate people, how can we put smart tech, help people get smart tech in their homes, to have AI do that so they don't have to do it. I just want to hit the button and let Google or Apple do it. I don't want to do it. So how do we get engaged with people to do that stuff so that they can bring their load down? If everybody saved 10% of $40 billion is a lot of money, right? So we're going in to build a microgrid at the Charm Lake, and we're talking to Kineseo. The first thing we want to do is say, let's get the load down so we don't have to build that much solar, that much battery, that much diesel, right? Let's get it down. Then you're thinking too, now the people are thinking, not just, I want to flip my switch and it comes on. We've optimized it. Total cost, right? Total societal cost approach,
or like building in some of these programs before you have a lot of the smart tech in place where people start to then get real time, because we can already shift the behavior before then we won't have as much of the lag when they actually get to the data.
Yeah,
Anyways.
we have a whole team working at that, and it's been a challenge. Everybody has to buy into that, including in our own company, and there's so much focus on so many different things. That one hasn't got the attention that I would say it should, but we're on.
We include that, like our long-term supply plans include a certain allotment of demand, customer programs, demand response and things like that. Like the reality, of course, what load is going to go up significantly. We're probably going to double the energy consumption of the province, and that's a good thing. And the world's going to double or triple their energy consumption as every jurisdiction goes to that, but we need to use energy wisely. And so, so putting in place tools to allow people to have some flexibility. How do you shift load around, which you may use the same amount of energy, but you may use it differently at different times of the day to avoid us having to build stuff and things like that. So there is programs. It just kind of gets hidden into things because right now it's a small part of, because we're seeing load go up so much that it's kind of going like this, and maybe it brings it down a little bit, but it's
gets us into that speculative area too. Like, how can we encourage people who have solar to put it in battery, and then when would we want them to dump it? We got to figure that out, right? So it all fits together in the DSM world. Yeah.
So one of the challenges too with industrial customers, a lot of customers, they may want to use it to bring their consumption down, but there'll be times where their energy will go up again. And even our residential customers who have these programs, you can design things around people reducing their energy consumption. But if it spikes up again at certain points, then we still have to build to accommodate that. So
yeah. When you buy a Ford Lightning, just think about that. It's literally you're tripling the load on your house instantly. How are we doing for time?
We are actually only about 15 more minutes is what we had scheduled.
Okay. I'll cook a little bit. Please keep asking questions. This is the conversation we wanted to have. So this shows our EV forecast. In 2023, we said, by 2030, 334, we'll have 142,000 EVs in the province. That seems reasonable with all the regulations and the trends we've seen. A year later, we think we'll have 217,000, 85,000 EV forecast increase. All the research we've done, we've seen every jurisdiction, they just accelerate the curve, that the adoption's faster than we thought. It's faster than we thought. And that's what's happening. I mean, there's a point where major manufacturers just won't be making ICE, internal combustion engine vehicles, right? So this is what we're facing. So what we've kind of concluded on is 5%, when 5% of the vehicles being sold are EVs, you go parabolic. We're thinking that's about 25, 26 in Saskatchewan. Even though everyone says Saskatchewan's different, so it's not, it is, and it's not. Infrastructure is going to come. Cars are going to have 400, 500, 600 kilometers of range. It's happening. Now there's a study by the Rocky Mountain Institute that in 6 years you hit 10%, 6 years later you hit 80. So 80% of vehicles on that basis, if you trust it, by 2030, 31, we're there. So thinking of our infrastructure on the grid, that I have to be ready with transformers and services to all your houses by this date that can serve X. That's a challenge. We've got our hands full. So that's where we have our hands full. So a lot of the innovation and the customer side technology management, we're looking to industry. We can't be all things to, so we need to partner with industry to say, what can you do to help people? Electricians, solar providers, battery providers, just, we need you working on the customer side to help here. So. This is just an overwhelming list of things, just to show you what we're dealing with, right? I mean, generation, there's all different types of generation that people are looking at, not just solar, biomass, people talk fuel cells. There's actually very small reactors. People are talking about 5 megawatt nukes. So we can't keep up with it all. So we have to stay in touch with industry to say, is this real? When is it going to be real? We're just going to work it into our mix, but we can't be all things. We need you to be the expert and come share with us, and we'll see if we can fit it into the grid. Energy storage can be massive just to move that energy around. Energy efficiency, number one, best place to start. Load management, that can, energy storage and generation can help us manage load, move it where we need it. And the electrification is, as Doug said, a good thing. We're moving that way for zero carbon energy, but massive load on the system, right? So, and I can't see the last column. So that's just other things. Microgrids. And the other one I want to share is black swan events. What could come out of nowhere that we haven't been thinking about? Like one thing we hear, the CEO of Mercedes has said, I see a time when instead of everyone having 2 EVs, We have a fleet, Google has a fleet, nobody owns a vehicle. You just call us up and we show up with an autonomous vehicle, and there's only 10% of the cars on the road. Hadn't thought about that, so why not? So that stuff can happen, right? What can you do today? Energy efficiency, lower your energy consumption, invest in smart devices to manage your own load. And if you can, participate in larger scale generation. Utility scale solar is about $1 a watt. Rooftops about $3 a watt. That's just an industry study. Obviously, economies of scale work. And investigate self-generation options. We do have that. We do have a net metering program. We're open to that, but we want to talk more about other options. I think I did it there, Laura, Corinne. So yeah, net zero is absolutely a top priority. When and how, how much impact will balancing cost, affordability, reliability. That's what it's all about. And it's going to take everything: distributed generation, centralized load management, energy efficiency, and all kinds of partners. So looking for your input. Thank you. It's great to talk to a university of educated or being educated people with opinions, and we need to reach out to you folks. So any questions? Awesome.
Thank you.
We'll have a couple of minutes.
In terms of the distribution system, what do you imagine the approach will be? Like, you're going to think about going to a neighborhood, making that like EV and heat pump compatible, like the whole neighborhood all at once, and then you can sort of tell people, yeah, you guys, we want you to electrify, you're ready, but
yeah,
everybody else over in this neighborhood, we don't want you to do it yet because the distribution system's not ready, or how do you want to approach it?
Absolute work in progress. What we started on is West Terra. We did an EV ready subdivision. So brand new from scratch, greenfield. Let's put transformers at every second or fourth house. And let's try to go Front Street. City's not keen on us being Front Street. That's where their water infrastructure is. But if there's no back alleys, we don't want to be in the backyard, or else we're digging up people's yards and boring. So we did an EV ready subdivision. Now we studied that. Things like air source heat pumps, whatever that might be, we're looking at it. Air source heat pumps, our research is it's only good till -20 or 30, then you're back at running electric heat on peak. So we want to incorporate all kinds of fuel choices, optimizing whatever we can. Brownfield is tougher. There's areas with alleys, we're okay. With no alleys, we're going through backyards. So we're gonna have some ugly decisions to make. But we're exploring all that. You have the answer.
Well, I know, I'm curious. Did you say you're saying every second house has a transformer?
Will in our new EV ready design.
Hey, would that be heat pump ready, or do you have to go to like every house has a transformer for?
Well, the problem is that's a transformer. So like we can't really start building for 2 lightnings and electric furnace because it would be a bigger transformer to every house. We can't. So let's start with a moderate approach to 20 kilowatt hours.
As an HVAC guy,
Yeah.
I can tell you, the HVAC community does not see electric furnaces as a big load in our jurisdiction. We have a huge gas infrastructure. We can do, and we have studies that show it. You can do heat pumps for about 85% of your consumption, and you're left with 15% of gas consumption for peaking, and it also acts as a backup if your heat pump fails. And you can implement it today. All the technology is there. They replace it with a furnace now, and the vast majority of new homes have air conditioners, and typically the heat pump load for heating, the cooling load for cooling are very similar. And so the electrical requirement for the house is virtually the same. It's only consumption that changes, not demand.
Yeah. And we hope so. That's what we're looking for.
Yeah. And so, one of the proposals we have right now is for at the university level here in our little working committee is for SaskPower to participate in a study that validates the work that was done, which was just done voluntarily by our operator. And so we want to get that validated in a study that has some due diligence to it, and you could bank on it.
Yeah.
And we see that as a interim step, particularly for existing infrastructure, what the path is. 95% of the load exists right now. The real answer, though, is as in an EV ready subdivision for heating and cooling, the answer is like Drake Landing in Alberta, which is a shallow geothermal, solar thermal backup. That answers your question, but you need somebody to act as a utility.
Exactly, and that's the challenge. I'm with you, Tom. Like here's where we're at. We have to serve the load. So we're actually not on the customer side going, we're just saying, what are you putting in? Right. And like we hear northern communities, First Nation communities or Indigenous communities saying, yeah, we might electrify the rest of the town. We're not really in a position to say you shouldn't. We have to say, if you do, here's what it would cost to do it. So we've got to get past that to say, can't afford. We've got to work with private sector industry to say that's not a good decision, or what else can you do because it's going to be challenged. Rather than just say, here's the cost and it's ridiculous, we've got to get a little more ahead of that and have conversations.
Yeah, I think though that you could be part of a multi-party group that comes up with a set of tools or a set of solutions that can go, and then every customer is going to be different. Yeah, and then they can look at those options and say, okay, this one suits this one groups.
You're absolutely right. We need a toolbox full of different tools for every different situation, and we can't do all of that. So you're absolutely right. We even need the people to get to do. We want to start doing that. That's why we're here. What can we do to engage with community, engage with other subject matter experts to say, what do you have? How can we're only one voice. We can't really tell people you can't do it. We can say, here's some other options. Are they real? We're not experts. Maybe talk to right? Yeah. Massive equation, right? Lots of variables.
Just a question on the CCS, adding that onto a plant. You know, one of the things you talk about is being more efficient, but it's a question for myself. Is a CCS plant less efficient? Because my understanding is you actually takes more coal to create the same amount of output of that plant with CCS on it. Is that
there's a parasitic load, which you're say when we convert a gas plant. So we're not going to be converting either coal plant
right.
to CCS, but if we convert a gas plant, you're gonna add the cost of the capture piece onto it, the maintenance cost will go along with it, and you actually decrease the net output of your plant because there's a fairly substantial parasitic load.
So we're kind of going the opposite direction, becoming less efficient to be more.
But it gets to the challenge of making that energy transition. If you have to continue to bring your emissions down, but you've got a limited set of options. And we can snap our fingers in 2035 and say, well, we'll just have 5,000 megawatts of nuclear power, or 5,000 megawatts of something not emitting on our system. We do it, right. But it's going to take time. So between now and 2035, we're going to need to continue to build natural gas. But it said, how do you bridge that gap between that point and 2050, where in 2050, presumably we'll have no emitting baseload generation remaining on our system. And somehow you got to make that transition, and maybe you do carbon capture and natural gas because you need to continue to run natural gas, but to allow you to run it and meet emissions regulations will be captured. So but again, it's a lot of, we're not alone in looking at this. Like we're meeting with industry, a lot of the potash industries, refineries and things like that are in the same boat where they need to get their emissions down, but they need to continue to utilize natural gas. And if you're a solution potash mine, your options are even more limited because you're a big consumer of gas. And so they need to find a way to bring their emissions down too. So they're looking at CCS, but they're also looking at advanced nuclear reactors, high temperature reactors to provide high temperature heat. So they're looking at the same things we have, but there's only a limited number of choices. So, in a perfect world, you just make that instant transition to the future, but it's going to take time.
In your 2050 outlook, how much consumer-driven production are you assuming? Like
Consumer-driven
production, power production.
Yeah, good question. I think when we look at the future, we know we're going to be net zero in the future. So there's different ways to get there. Certainly, I think our customers in the future, a lot of them are going to have solar panels on the roofs and things like that. I think there's going to be a lot of industrial customers with home generation on it. So the big question, like how much of that is the customer. I don't think we have. When you look at it, we don't have a projection of exactly where that energy comes from. Aside from we know it's going to have to be non-net, so that some portion will come from the customer. Certainly, as you start to advance towards 2050, you'll start to see. Right now,
Just a quick point about those EVs. If you have two of them and you drive less than 50 kilometers each on them, you can just plug into the wall. It doesn't need the high do that to get them charged overnight. You'll never see that peak worst case scenario.
Yeah, thanks. We're talking about a lot of different scenarios there. Like we actually said, you know, in the city, 20K, 20K. In White City, Strasbourg, all of a sudden, where's the charging gonna happen? Geez, maybe it's in Strasbourg and not really, right? Or our municipal buildings and business owners can allow people to charge at work. Well, we have commercial charging there. One guy facetiously said, "Give them free charging at work, so they don't charge at home and we kill the infrastructure." You know, so everything's on the table.
That's a great idea.
Don't quote me on that. Yeah. I mean, everything's on the table because we have to figure it out. We need more data to make those decisions.
All right, I think we'll thank our speakers again. I think it's been great, all the discussion we've had. I want to remind you again on the 26th, we will have a symposium. It's in the Education Auditorium, followed by a sort of a get-together informal discussion, much like we've been having today. But really, Corey, and thank you so much. It's been really, really good. Thanks.